Let us discuss a topic on mathematical induction. In this, the related formulas will come in this chapter. These are related to the 10th class. That is, sum of the natural numbers is 1 plus 2 plus 3 plus so on plus n terms. The nth term is n, that is equal to n into n plus 1 by 2. The second one is 1 square plus 2 square plus 3 square plus so on plus n square equal to n into n plus 1 into 2n plus 1 by 6. Third formula is 1 cube plus 2 cube plus 3 cube plus so on plus n cube equal to n square into n plus 1 whole square by 4. In this, the problems are related to mathematical induction means in this we follow the three steps. The first one, if they have given the statement for each and belongs to how to solve the problem. The steps of the solving of the problem, the first one is for each small n belongs to capital N, let P of n be a statement. They have given the one statement, that is, let it be P of n be a statement. Why? The statement has n terms. So it is a statement in that, suppose that first condition we can show that when we substitute in the place of n equal to 1, the statement is true. That is the first step. The second step is, the second condition of in this method is, that is second step, for any small n belongs to, or already they have given the nth terms, let it be in the second step, for any small k belongs to capital N, if P of 1 comma P of 2 so on, P of k is true. That is, we can take, if it is true, then we can prove that the statement is true for k plus 1 terms. That is, P of k plus 1 is also true. The statement is true for k plus 1 terms. Then, by satisfying of these two relations, simply the nth term of the statement or the given statement is true for n terms. That is, P of n is true for all small n belongs to capital N. This is the procedure of the finding of given statement, is it true for n terms. Okay, by the method of the mathematical induction. The mathematical induction method is, first the given statement is true for n equal to 1. We can take the statement is true for n equal to k. We can show that the statement is true for k plus 1 terms. If the statement is true for k plus 1 terms, the given statement is true for all small n belongs to capital N. Okay, this is the procedure of the problem by using of the mathematical induction. Now I am taking one problem and let us discuss about the solving of that problem by using of the mathematical induction. The first question is, using the mathematical induction, it is exercise 2a. First question, using the mathematical induction, prove each of the following statement, or prove that the statement is true prove that the statement for all small n belongs to capital N. The first question is 1 square plus 2 square plus 3 square plus so on plus n square is equal to n into n plus 1 into 2n plus 1 whole by 6. Is it true for that n values or not? By using of mathematical induction, we can prove that. Already we discussed the sum of the natural numbers and square of the natural number sum, cube of the natural number sum. This is the first question is related to square of the natural number sum is equal to n into n plus 1 into 2n plus 1 by 6. First, take the given statement p of n is equal to 1 square plus 2 square plus 3 square plus so on plus n square. It is equal to n into n plus 1 into 2n plus 1 over 6. First case 1. To prove that the statement is true for p of 1. That is, take n equal to 1, substitute in left hand side and right hand side. LHS equal to, in the place of n substitute, that is 1 square equal to 1. In the RHS, right hand side terms are, in the place of n, 1, 1 plus 1, 2 into 1 plus 1 over 6. That is equal to 1. 1 plus 1 is 2. 2 ones are 2 plus 1 is 3 over 6. 2 ones are 2 threes are 3 ones are 3 ones are. So it is equal to 1. Here clearly LHS equal to RHS. So the statement is true for n equal to 1. We can tell that P of 1 is true for n equal to 1, which is belongs to capital N. The second one, we can take the statement is true for n equal to 1. Let the statement is true for n equal to k. That is, P of k is true. Okay. Here what is the P of k? 1 square plus 2 square plus 3 square plus so on plus k square equal to k into k plus 1 into 2k plus 1 over 6. Simply substitute in the place of k. Here we can take P of n is a statement. That is okay. Now what we can show that, to show that or to prove that P of k plus 1 is true. So in that case we add on both sides k plus 1 term, k plus 1th term. What is the k plus 1th term? T of k plus 1, the nth term of k plus 1 equal to k plus 1 whole square. That is k plus 1th term. Adding on both sides, that is 1 square plus 2 square plus 3 square plus so on plus k square plus k plus 1 whole square. This k plus 1 whole square adding on both sides means k into k plus 1 into 2k plus 1 over 6 plus k plus 1th term is k plus 1 whole square. Here, the left hand side is k plus 1, it's clear. But right hand side, you remember k is replaced with k plus 1. That is true for p of k plus 1. For that, we can take the simplification on right side. Here, k plus 1 is common in two terms. So take the outside k plus 1. Remaining terms of the first term is 1 into 2k plus 1 over 6 plus k plus 1. Take the LCM. K plus 1 is a factor right outside, and take the LCM. 6 is the LCM. For the second term of that, we multiply and divide with 6. So k into 2k is 2k square plus k into 1 is k plus 6 into k is 6k plus 6 into 1 is 6. It is equal to k plus 1 over 6 right outside, and simplify the bracket terms. 2k square, okay, k plus 6k is, it is 7k plus 6. The second factor is in the quadratic form. We can split as linear factors. So here 2 6 are 12. 12 factors are 4 3s are 12, 12 1s are 12, okay, 6 2s are 12. Here, which is the suitable factor? 6 2s are 12 means 6 plus 2 is 8. 6 minus 2 is 4. It is not suitable. 4 plus 3 is 7. So 7 can split the middle term. So first one is k plus 1 over 6 is right outside. The quadratic form can split into factors means 2k square plus 4k plus 3k plus 6. It is equal to k plus 1 over 6. In the first two terms, taking 2k is common. In the first term, k is the left of the term, and in the second one is 2. In the last two terms, taking common 3, 3 into k plus 2. 3 2s are 6, 3 into k, 3k. 2k into k, 2k square, 2k into 2, 4k. Okay. Next, k plus 2 is common. K plus 1 into k plus 2 is common. This is 2k plus 3 over 6. This 2k plus 3 can write it as 2k plus 2 plus 1. 2 is common, k plus 1 plus 1. So, which is expressed in the form of k plus 1 into k plus 2 into 2 of k plus 1 plus 1 over 6. So each and every term is replaced as k with k plus 1. It is the k plus 1, it is k plus 1 plus 1, 2 of k plus 1 plus 1. So the right hand side is also expressed in k plus 1. So simply it is true, or the statement is true for p of k plus 1. Or simply we can tell that p of k plus 1 is true. By the mathematical induction, it is true for n. It is true for small n belongs to capital N. That is 1 square plus 2 square plus 3 square plus so on plus n square equal to n into n plus 1 into 2n plus 1 over 6. This is the method. It carries the 7 marks. Okay.